Today we're beginning a new chapter on graphs and functions, and our first lesson is on graphing equations. Of course, here are the objectives for the lesson. I'd like for you to jot down in your notes, please. Vocabulary, there's quite a bit of it. There's the ordered pair. It's a sequence of two numbers where the order of the numbers is important. If you remember correctly, the x value is first and then the y value. The axes are the horizontal and vertical number lines. So we're talking about a Cartesian coordinate plane with the axes, and the origin is the intersection of two axes. Notice axes is the plural of axis. Axis is one line, axes is two. Regions created by the intersection of two axes are the quadrants. There are 4 quadrants on the rectangular coordinate system, the Cartesian coordinate plane. Location of a point residing in the rectangular coordinate system is created by a horizontal, which is the x-axis, and the vertical, which is the y-axis, and can be described by an ordered pair. Each number in the ordered pair is referred to as a coordinate. To graph the point corresponding to a particular ordered pair, here it's referenced as AB, you must start at the origin and move A units to the left or right. So you move left or right first. Right if A is positive, left as A is negative. Then move B units up or down, and it goes up if B is positive and down if B is negative. A lot of this vocabulary you're going to find on pages 118 and 119. You might want to pause the video and make a note of this in your notes as well, where the x and the y axes are. Notice the quadrants are labeled in counterclockwise. Quadrant 1, then quadrant 2, quadrant 3, then quadrant 4. To graph a coordinate 5, 3, you go 5 units right and 3 units up. Look at the difference between 2, -4 and -4, 2. On 2, -4, you go 2 units right and then 4 units down. However, on -4, 2, you go 4 units left, then 2 units up. So the order is extremely, extremely important. There's paired data. That's data that can be represented as an ordered pair. A scatter diagram is the graph of paired data as points in the rectangular coordinate system. So they're just points that have been plotted on the Cartesian coordinate plane. They're not necessarily make a line. An ordered pair is a solution of an equation in 2 variables, and if replacing the variables by the appropriate values of the ordered pair results in a true statement. So if it results in a true statement, it is indeed a solution to that equation. For example, we need to determine if the ordered pair 3, -2 is a solution to this equation, or does this point lie on this line? So if we're going to let x equal 3 and y equal -2, we simply substitute it in by replacing the x with a 3 and a -2 with a y, and see if it forms a true statement. Is -4 equal to -4? Yes, that is true. Because this forms a true statement, you know this point lies on that line. Now determine whether -1, 6 is a solution to 3x minus y equals 5. Again, this is the x value. Always the first value is x, the second value is y. So we substitute in. Is -9 equal to 5? No, that is false. So this ordered pair does not lie on this line. It is not a solution. Linear equation in 2 variables. You can find this chart on page 121 of your text. A linear equation in 2 variables is an equation that can be written in the form ax plus by equals c, where a and b are not both 0. This is called standard form. You will know a linear equation is in standard form when all the variable terms are on one side of the equation and the constant is on the other. Okay, we're asked to graph the linear equation. Notice it's in standard form because the x and the y are together and the constant is over here by itself. We find two ordered pair solutions, and we're going to find a third solution to check our computations, just to make sure our math is correct. And we're going to do that by choosing a value for one of the variables, x or y, then solving for the other variable. We plot the solution points, then draw the line containing the 3 points. You can choose any value for x or y. So if you choose a value for x, you're going to solve for y. If you choose a value for y, you're going to solve for x. Keep the values small enough so that they'll graph easily. You don't have to have a large graph in order to graph it. So we're asked to graph the linear equation, and this is arbitrary. We're just picking x equals 1. Like I said, pick small numbers. So in place of x, we're going to put a 1, then we're going to solve for y. So we're simplifying. We're going to subtract 2 from both sides. Notice we have a negative y. We're needing to solve for y, not negative y, so we multiply both sides by negative 1. So y is equal to 6. So when x is 1, y is 6. So you can plot that point. However, we need 2 more. How about this time? Let's solve for y equals 4. Doesn't matter what you choose, you're just picking a value for y, substituting it in, and solving for x. So this says that when y is 4, x is 0. So this ordered pair is 0, 4. Remember, the x value always goes first. Now we're going to pick a third solution. This time we're going to let x equals negative 3. So in place of x, we're going to substitute it in with a negative 3 and solve for y. Again, we have a negative y, so we're going to have to multiply both sides by a negative 1, so y is equal to negative 2. So when x is negative 3, y is negative 2. That's our third solution. Now we're going to plot all 3 of the solutions, and then we're going to draw the line that contains all 3 of those points. Note that a line contains an infinite number of points, and each point corresponds to an ordered pair that is a solution of its corresponding equation. So any point on this line is going to be a solution to that equation we were working with. Now we're going to graph the linear equation y is equal to 3/4 x plus 3. How many of you just love working with fractions? But I didn't hear one of you enjoyed that. So to avoid the fractions, what we're going to do is for the x values, when we choose x values, we're going to choose multiples of 4 so that it'll end up eliminating that fraction. So let's start with the number 4. When we substitute it in for x, notice the 4's will cancel out. We end up with 3 plus 3. So when x is 4, y is 6. Now let's let the second solution be 0. Again, we'll be eliminating that fraction when we let x be 0, because anything times 0 is 0, right? So when x is 0, y is 3. There's our second solution. We need one more because we're checking our computation. We've already used 4, we've used 0, now let's use negative 4. We'll still get rid of the 4, except this time we'll be multiplying that by a negative 1. This 3 by negative 1. So 3 times negative 1 is negative 3. Or you can go, if you're not really familiar with fractions, 3 times negative 4 is negative 12. Negative 12 divided by 4 is negative 3. Okay? And negative 3 plus 3 is 0. So when x is negative 4, y is 0. Now we're going to plot all 3 of these points and draw a line connecting the 3 points. So any ordered pair that falls on this line will be a solution to that equation. We just made it easy because we got rid of the fractions. Next, we're going to look at intercepts of axes. This is where the graph crosses the axes. You'll also find information on the intercepts on page 123 in your textbook. Since all points on the x-axis have a y-coordinate of 0, to find the x-intercept, just let y equal 0 and solve for x. And by the same token, all points on the y-axis have an x-coordinate of 0. So to find the y-intercept, you're going to let x equal 0 and solve for y. So what does that look like? We're asked to find the y-intercept. We're wanting to see what y is equal When we want to find out what y is equal, let's put a 0 in for x to get rid of it. So that's just going to leave 4 equals negative 3y. Now we divide both sides by negative 3. So it is going to cross the y-axis at negative 4/3. The y-intercept will be 0, negative 4/3. Notice the solution, 0, negative 4/3. Let's find the x-intercept. When we're trying to find the x-intercept, we're going to have y be 0. Anytime you multiply anything by 0, it gets rid of that variable. That's what we're trying to do so we can find out the answer to the other variable. So this point is going to be 4, 0. That is the x-intercept. Plot both of these points and draw the line through 2 points. You should still find a third solution to check your computations, just to make sure you're doing the math correctly. So let's let y equal 1. Substitute in a 1 in for y. Simplify the right side, add 3 to both sides, so x is 7. So 7, 1 is the other solution. Now let's plot those 3 and draw a line that goes through all 3 points. Let's look quickly at graphing a parabola. Here we have a quadratic equation, and we know that the graph is always going to be in the shape of a U. Let's use a table of values. So we're picking values for x. Notice I'm keeping them small, and I'm using negative and positive numbers that are the same distance apart so we can find out what y will be. So if we put a negative 2 in for x, negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Like I said, you're picking these numbers. They're not giving them to you. But then we graph those points and connect it. So there we have a parabola. Absolute value. If you remember, absolute values are in the shape of a V. Again, we're picking the same values for x. Plot the points, but this time it is a V. And finally, a square root function. You cannot have a negative square root and still be a real solution. So you know that everything you're going to choose here when you've got square root is going to be a positive number. And it's going to be in quadrant 1 because all your x's will be positive values. Now it could go here if there's something added or subtracted from it, or there's a negative. Okay, you're ready to begin working on your assignment.